Meet SAE International. You might not know us, but we've been with you. For the past 100 years, we've been revolutionizing transportation and mobility, partnering and supporting the dreamers, innovators, and can-doers who are changing the world. It's the child whose future career as an engineer will be shaped by our STEM education programs. It's the businesswoman boarding her flight with peace of mind, knowing that our committees have created the standards that ensure she gets from Detroit to Delhi and back again safely. It's the parents-to-be who are sleeping soundly, knowing that their electric car is fully charged and ready when it's go time. Driven by a passion to advance mobility knowledge and solutions, SAE's global community of over 200,000 engineers, technical experts, and volunteers continues to develop and curate the most reliable and comprehensive collection of engineering resources and consensus-based standards on Earth. The next mobility revolution is upon us. Connected and automated, electrified and sustainable. SAE will be here, as we have for the last 100 years, moving the world forward.
All right. Good morning, good afternoon, wherever you are. My name is Mo Abu Ali with IoT Company, and it's a pleasure to partner with SAE Detroit section on the webinar today. So I really appreciate your time. The session will be recorded, and you'll receive a copy of the recording. And if you're interested at the end, please shoot me an email, and I'll share the slides with you. And last but not least, please use the chat function whenever you have a question. Just please pop your questions in the chat window at any time, and we'll address it at the end. Also very pleased to be co-presenting here with Dr. Dimitris Agrotis. I'll cover the first part of the presentation, and then Dr. D, as we call him, will continue with some case studies. So let's go ahead and get started. Again, my name is Mo, and I've been in the industry for over 23 years. Half of my career I spent working in the Japanese industry, working with Toyota manufacturing and other suppliers. And I'm an industrial engineer by trade. I've been with IoT Company as a co-founder and managing partner for about 7 years, providing Industry 4.0 solutions to the automotive industry. Very quick introduction, who we are as a company. Our DNA is the automotive industry. We were born out of automotive, working at companies like Toyota and the tier suppliers, but we serve discrete manufacturing with smart factory solutions. And some of the solutions include plant connectivity, manufacturing execution, but the focus today is more around artificial intelligence and leveraging predictive analytics on the shop floor. But we will show you some case studies, across all different tools of Industry 4.0. We're also, in addition to partnering with SAE, we're also proud to partner with the National Association of Manufacturers, NAM, and they have a Manufacturing Leadership Council. Some of you may be on that council, or you may have heard of the council. They have an annual Artificial Intelligence Analytics Leadership Award category. And we're proud to announce that this year, 2 of our customers actually received the awards. One was for predictive maintenance implementations, and one was for predictive quality implementations. And actually, Hino Motors, which is a Toyota subsidiary, was one of the recipients of the awards. And we'll share with you some of the technology they're using in the presentation today. So that was just a very quick who we are. But today's presentation will be very educational and informative. We're going to cover 4 things. I'll cover the first 2 points. What is Industry 4.0 and setting the stage for how Industry 4.0 is adopted and implemented today, with big focus on the automotive industry. I'll talk and focus on artificial intelligence and predictive analytics use cases. And again, very pleased to have Dr. Agrotis talk about real Industry 4.0 case studies in his automotive companies. And last but not least, we'll have at least 5 to 10 minutes for Q&A at the end. And again, if you have any questions whatsoever, just please drop them in the chat window at any time. So many of you may have heard the term Industry 4.0. Many of you may be embarking on your Industry 4.0 journey as I'm speaking. And that's the primary focus of today's presentation. Industry 4.0 is the fourth industrial revolution. It's really about marrying traditional manufacturing methods with the digital world. It's about the convergence of information technology and operational technology, IT and OT. Sometimes we say it's about shop floor to top floor integration. So at the shop floor level, you have machines, you have CNCs, PLCs, you got new machines, you got old machines. And at the top level, you have your business system, your enterprise resource planning, your SAPs and Infors and Oracles of the world. But right in the middle, in many companies today, there is a gap. There is maybe paper on the shop floor, or there is manual data being collected. There is limited connectivity to the key equipment. So Industry 4.0 is really about transitioning companies into a connected smart factory. And it's about four pillars. And I like to start from the right and go backwards. Return on investment. It's about the business case. To really have a win with Industry 4.0, we must start implementing pilot projects that prove value in the key areas, in the critical plants and the critical assets. So that drives return on investment, improving uptime, improving quality, and other key metrics. And then it goes into connectivity. So how do I capture real-time data from sometimes siloed layers that I have within my operation here? I got my machines, I got my data acquisition. In some cases, I have an execution system of some sort or an IoT platform. So connectivity and real-time data capture is key to success. And then what do I do with the data? And we're going to cover some use cases around analytics today, and especially predictive analytics, so you can gain insights into maintenance issues and quality issues in your factories. And then last but not least, how do I select the right technologies for my business, and how do I scale those technologies across, in some cases, multiple plants across multiple geographies? So Industry 4.0 is really here to stay, and a lot of companies are transitioning or have transitioned from a 3.0 mindset to a 4.0 mindset. And it's about people, process, and technology. And it's about delivering business value. What you're seeing here are a survey we conducted, and some of the results that manufacturers have achieved by implementing pilot projects. So within 3 to 6 months of implementation of a pilot, these are true numbers showing improvements from different Industry 4.0 use cases. One of those use cases is data capture, visibility, and tracking metrics, like your overall equipment effectiveness, your OEE. Other use cases are leveraging artificial intelligence and advanced analytics to drive predictive maintenance and even predictive quality. There is opportunities to improve your spare part optimization, to do better planning of maintenance activities, labor, and spare parts, and to really drive improvements in your mean time between failure, mean time to repairs. Predictive quality is also an advanced use case that we'll briefly touch on, of how you can correlate asset data or process data to actual scrap or defects that are happening on the machine. So we talk about asset health and we talk about process health, and both of which drive you towards a zero downtime, zero defects mode of manufacturing. So again, business case first, technology follows. Think about the business case that makes sense to your business, which critical plants, which critical assets, and think about people and process and technology elements to be successful. It's also important to agree on and admit that different companies have different levels of digital maturity. This here is based on the Fraunhofer or the Aachen Institute model, which defines Industry 4.0 development path over time. Again, nothing wrong with the score, but it's important to assess your maturity level. Some organizations are still at level 2 or level 3. They're working to get connected, and they're working to capture real-time data on the shop floor. And that allows you to enter the age of Industry 4.0 by seeing what is happening in real time, becoming visible, by then understanding root causes and drill downs of issues that are happening, so-called transparency. So by implementing execution systems for production, quality, traceability, maintenance, for example, and then leveraging AI and advanced analytics and becoming more prepared and becoming more predictive and proactive. And then in some cases, becoming even prescriptive meaning self-optimizing in an autonomous way and adapting to changes on your shop floor and changes in your supply chain. So, we as an organization, we conduct Industry 4.0 assessments, and there's many other organizations that do. Consider embarking on an assessment to kind of help you understand what is your level of maturity, and then what is a roadmap within the next 1 year to 3 years, short term and long term, and what Industry 4.0 tools that you need to put in place depending on your maturity. And speaking of tools, we refer to these as digital tools of the trade. These are Industry 4.0 tools. It's not a complete list, but these are some of the key tools that you can implement to become more visible, transparent, and predictive. And Dr. Dimitris will show real case studies from automotive companies that have adopted, different tools in different environments based on their business requirements. I will initially talk about predictive analytics as an important tool, and then hand it to him to give you real case studies from every vertical here, from IoT to AI to assessing and training your team on Industry 4.0 and collaborating with organizations like SAE and others to do that. So before I go deeper, what is AI? There's a lot of case studies out there. This one is one of my favorite. This analysis defines artificial intelligence, AI, as a science of capturing data and getting computers to act intelligently without being programmed. It learns, and computers can learn from receiving data and using algorithms to train the data and test the data. And within AI, the subset is called machine learning, and machine learning is a subdiscipline that utilizes those mathematics and statistical algorithms, and you can train those models with baseline data that would allow the models to learn and run in a real-time fashion. Most recently, there's also the science of deep learning, which is a further subdiscipline, and deep learning is widely used in, for example, machine vision applications that are using cameras taking pictures, and from the pictures they're inferring, if there's a part quality or a scrap prediction issue on a specific machine or line. So we're going to talk about templates and use cases for leveraging AI, and specifically leveraging machine learning to support you in understanding your asset health and understanding your process health and becoming predictive. So some of the use cases we wanna touch on today. There's really two key use cases, and I'll show some examples: predictive maintenance and predictive quality. Understanding there is machine learning algorithms and AI implementations that need to be in place. And then all the way on the left of the picture is your data lake. This could be data flowing from your machine controller, from OPC servers and historians that you have. It could be add-on sensors like vibration that may need to be added to the machine. Or it could be just unstructured data, like, as I mentioned, cameras or machine vision. So it's important for an AI solution to have interoperability with a variety of data sources to allow the AI solution to understand what's happening, process that data, and then have a user experience all the way on the right to support the maintenance organization and the quality organization to become predictive and diagnostic. And right here in the middle is a process, a systematic process. AI and machine learning is a science, as mentioned, and this science can be implemented in any environment in a 6-step approach. And the first step is data, relevant data, depending on the process, whether you do machining or casting or molding or whatnot. And then the machine learning analytics, like a workflow, to process the data, to extract metrics, so-called features from the data, and then to train a health model. And then as the health deviates over time, you'll be able to predict future issues. For example, when will the asset or the machine go down before it goes down? Or when will I start making bad parts and my process deviates on my machine or line? And then last but not least, what's a diagnostic? So rather than doing trial and error and trying to run this process in a manual fashion, we as an organization and many other organizations have a library of solution templates. These can accelerate the implementation of AI on the shop floor. It can be implemented in days and weeks versus months and years. So when we look at what is critical in manufacturing today, some of the most expensive equipment and the most uptime and quality critical equipment, we're talking about robotics, machining, casting, molding, welding, stamping, press machines as an example, but also ancillary equipment surrounding the factory. Your pumps and chillers and motors and gearboxes, also your facilities equipment like your compressors and chillers. So we picked a few of these templates today just to give you an introduction into how AI can be implemented. But again, if you are interested in certain templates that we don't cover today, just shoot me an email. We'll share with you the slides and we're happy to talk to you one-on-one. First example is on robotics. There is technologies out there that can monitor each joint or each axis of the robot and simply do it by capturing data from the PLC. So the torque, the current, the speed, the position, for example, of each joint, each axis of the robot can be used to predict with a very high level of accuracy different failure modes that are shown here. Belts and backlashes, bearing failures on the axis, motor brake failures. This can be robot agnostic, whether it's a FANUC, KUKA, ABB, whatever you have. With the ability to capture that data from the PLC controller, predictive maintenance can be implemented in a short period of time for critical robots in the factory. And some of the user experiences are also very important. It's important to implement these solutions in an intuitive way for the users. Again, designed for the user. The user is a maintenance professional. They are good at fixing machines. So do not expect the user to be a PhD or a data scientist. So these solutions are implemented not for the PhDs, but for the maintenance professional to understand, is my machine healthy? What is a prediction of when this machine will fail? So you can receive alerts and notifications before it fails. And then what is a diagnostic? What is the root cause? Is it joint number 5 on my robotic? So I can fix that joint and not waste time or labor or spare parts. So user experience is key for success in Industry 4.0 and AI applications. And another quick example is machining. Whether you're doing lathes or milling or turning or grinding in automotive, there's a lot of moving parts. It's complex. There's a spindle, there's a tool, there is a ball screw linear axis system, there is a coolant system. So some of these, again, can utilize CNC controller parameters, such as the ball screw, using the position of the ball screw as an indicator of degradation, but also on the spindle and the tool, using an off-the-shelf vibration sensor, installed on the spindle housing, and then leveraging AI would enable a manufacturer to catch these critical spindle failures before they occur. The whole idea is moving away from a preventive approach to a proactive approach of doing maintenance, using affordable sensors and hardware off the shelf, and having an intuitive user experience, such as, again, looking at the health of the spindle, predicting spindle failures before they occur, and understanding what is contributing to the spindle failure. For example, which harmonic relates to the inner race failure of the bearing or the outer race failure of the bearing. So becoming truly diagnostic in what you're doing on the shop floor. Last but not least, two quick use cases. One is more on the ancillary equipment. A lot of moving parts here. You know, what is critical for you? Is it pumps? Is it motor conveyor systems? Is it valves? We've recently started implementing a project with one of the biggest logistics sites, fully automated logistics site of a large heavy industry manufacturer, and it's you know, sending the repair parts to the excavators in the field. So there's hundreds of motors and critical conveyors that are automating the movement of the goods. And if one of these motors fails, it shuts down the conveyor, and therefore it delays the delivery of the part. So it is uptime critical. So by implementing affordable sensing of measuring current and vibration, predictive maintenance is able to give a lead time of, in some cases, 2 to 4 weeks lead time before the motor fails, so that the motor and conveyor systems can be repaired in a very timely fashion to allow on-time delivery to the customers. Last but not least, predictive quality, you know, is a whole science in itself. In some environments, such as casting, in this example, high pressure casting, low pressure casting of aluminum, the cost of scrap can be very high in the business, with scrap rates that could be 9 to 10% on average. And if you don't catch the casted scrap in the foundry on the machine, it becomes very costly to find that part and rework that part and scrap that part. And you can see here a real example from an automotive tier supplier that has over 100 casting machines across their plants. You know, early scrap detection and prediction can be 70 to 135K in actual savings for a mid-size manufacturer that has maybe 25 to 30 casting machines on the shop floor. So, you know, we partnered to not to implement predictive maintenance, but to implement predictive quality on the shop floor and actually capture over 50 data parameters for every cycle the machine is running. And the 50 data parameters are correlated to whether a good part is being produced or a scrap part is going to be produced. So early scrap detection and prediction in a predictive fashion in the automotive industry. And not only that, but the AI solution was also able to prescribe an action. So prescriptive analytics is about sending data back and making a decision without the human in the loop. So, you know, given the 50 parameters, if scrap is predicted, the AI sends a message back to the robot on the casted cell, and the robot, which is shown here, an ABB robot, would pick up the part automatically and would auto segregate the part. Is it a good part or is it a reject part? So it's a true multivariate analysis of a big data project correlating to scrap, predicting scrap, and then prescribing an action to segregate the part automatically. Significant ROI for the business. It had its challenges, of course, in terms of connectivity and data capture, but the solution was implemented in under 3 months at an automotive tier supplier. So some quick lessons learned, you know, start small, fail small, but don't be hesitant to start. If you have data, how can you leverage data towards improved maintenance and quality? You know, machine learning and AI is not magic. It requires expert support. We call it explainable AI. Pick a high value problem, involve your experts and bring domain knowledge to improve the analysis. You know, it's a partnership model, and then focus on something that drives a business case in the very short term. With this, it's really my pleasure to also invite Dr. Agrotis, we call him Dr. D, to share also some real stories from the automotive industry in his companies of how they're implementing Industry 4.0 today. Dr. D, thanks for being with us, sir.
Thank you, Mo. Good afternoon. Just a little bit of background. I have 4 daughters. I live in Hilliard, Ohio. I got my education here in the US, most of it at Ohio State and University of Dayton. I've held various positions in my career, both operations, engineering, as well as P&L. And I'm currently a director with the Charlton Group. and I have been working with IoTeco for a couple of years now. Well, you go to the next one. So the Charlton Group owns many companies. We have equity in many companies, as well as we support many organizations, most of which are in the automotive industry, I would say 90%. And because we own these companies, we're obviously interested in their productivity and their ability to meet their customers' needs. And just from my background, to tell the audience, obviously all being automotive, we all know Lean. And Lean is something that is now embedded in operations in the automotive industry. And I consider Industry 4.0 the next step, the digitization, if you will, of Lean, and the ability to predict. And obviously to do all those things, you need data. And I think Mo touched quite a bit on how that is transferred, and that there is a stepwise approach of how to take an organization and apply these tools. And the tools are applied either based on a need or based on the state of the company. And what I mean a need, it could be a requirement from a customer. I will show you an example here, or a desire of the manufacturer to improve their capabilities, okay, become more predictive as opposed to reactive. Well, you're gonna go on the next one. So again, Mo covered the space, if you will, of Industry 4.0. Industrial IoT, connectivity, automation, performance analytics, and then MES, the artificial intelligence portion that he showed you a couple examples, and I will share with you an example where we used AI. And then finally, the IoT Academy, or what we call a manufacturing advisory part of what IoTeco does, which is also a necessary element for someone implementing Industry 4.0. We need to understand the current state. So the last example I will share with you is one of the companies we acquired that effectively didn't know where to start. So you go in, there is a very structured procedure of how to do that, and I will share that down the road. Next one, Mo. So the first example relates to a company called BWI. They manufacture suspension and braking systems. The specific plant that we visited was relating to MES, and it is in Indiana. Mo, you know, go down. So again, what we're trying to do, obviously, is to bring value, right? To bring ROI, and to bring ROI, we want to make sure, first of all, that when we bring it, it is you're able to scale it, take it across different plants, and we want to do this quickly. And in this specific case, as you could see, there is an MES software called Shop Floor Online. It has many elements, but in the journey of BWI, the interest was in the ones that are highlighted, which was relating to production operations as well as quality. Okay. So again, the slide here actually is one that I requested from the operations team at BWI. And this is actually the company's feedback that was given to me. And this is what they have realized. And I want to make you aware that this project is in pilot phase. It's about to finish in a few weeks in the pilot. And then once it finishes in pilot, it would be scaled and propagated to other plants, as well as expanded. The yellow boxes that I showed you in the previous slide will now have more and more of those applied. But effectively, they improve reporting times. They remove from paper charts to MES for management their reports. They improved reaction times. Engineering is using the MES to determine first-time quality and downtime problems. And the control plan checks can now be recorded and enforced. And SPC for collected data is working and allows engineers to see problems. The bottom line, the organization is using less labor to manage the data, and the engineers are able to react on the problems in real time, as opposed to wait for the next day and someone to gather the data or look at the spreadsheets or plot a graph to get a trend or whatever. So these are real benefits realized within under 2 months, okay? And based on what I have seen in the past, we expect to see a lot more capabilities and results from this project. The next project is one with a company called Mobex. It relates to a manufacturing execution system, again, MES. What we wanted to do with Mobex was traceability. There was a requirement from a customer, one of their customers, to ensure that the birth certificate of the part is available. And you could see on this chart, the birth certificate has the dates of manufacture, quantity manufactured, when are they released, who released the operation, and so on and so forth, including all the process parameters that they were used. So an example at the bottom, this is just an example, effectively said, if I was building a phone with part number TN60 and a specific serial number, I need to be able to share what the case part number I use, what's the screen part number, what's the keypad, and so on and so forth. So it's, again, a requirement that would be very, very hard to do without a traceability system in place, if you could imagine to do this with Excel spreadsheets or anything else. Mo, you want to go on the next one? The next slide shows you the actual example. It was effectively manufacturing of knuckles for Dana for a Ford program. You could see the full line. We effectively installed the traceability system, and we're looking at operation 5 and operation 40. And the execution of the traceability has to do, again, with data acquisition, and planning is also very critical. In this specific case, this requirement from the customer came into Mobex early enough that allowed the company to move into the suppliers and actually install the data acquisition tags, or make sure that the manufacturers of the equipment had the appropriate data acquisition tags on their controllers, so the traceability or the data availability was ready as soon as the system was put in place. So again, another real example where the technology is enabling a manufacturer to meet a customer requirement. And by the way, these types of requirements are becoming more and more critical, especially in systems that, as we're moving forward with autonomous driving systems and so on and so forth, when you're dealing with safety systems and autonomy, we have to make sure if there is a failure, we can go back and find out exactly where the failure is and see if it's affecting other vehicles, or is it just a one-off. Again, in order to get the data, we had to deal with plant connectivity. So we started with a plant connectivity audit, and the steps are, we're looking at the machine. If the machine is network ready, is the machine connected into the network to make the data available? And then is the machine data map documented? And again, what is a data map? It is the necessary data that we need to gather to be able to make sure that we can trace and create the birth certificate for this product. So in this specific case, it was Allen Bradley LLCs with Ethernet cables. We connected them to the IP, gathered all the data. We knew the lots, the lower and low costing. We looked at all the critical operations, and then once that is available, the data can be logged. Now, what is important with this system is now the manufacturer has a cell that has sufficient data available, not only to create a birth certificate, but actually to allow them to go to the next step, and now using this data to start doing predictive analytics, okay, just like Mo shared before. So again, it's a procedure, it's like continuous improvement, but the fundamental element is the data. Once you have the data, Industry 4.0 tools will allow you to become much, much smarter. Next one, Mo. So the next one is a predictive analytics example, really AI, and it was with Dura in Czech Republic in a plant that manufactures battery trays. Now, one would say the plant is manufacturing battery trays, which means it must be a new plant because this is when the new electrification is growing. So why would anybody who just bought brand new equipment, okay, go and invest in predictive maintenance as opposed to predictive quality, since the equipment, instead of a predictive maintenance, instead of preventative maintenance, the equipment is brand new. So someone would say, well, as long as I do my preventative maintenance should be good. Well, the ROI is actually what is driving this thing. And when you have an organization such as Dura in Czech Republic that has very high demand from the OEMs, from their customers. And when you invest your capital, which is obviously an expense, you need to make sure you have a good return on investment. So you have two choices. You either overcapacitize to make sure that if you have a downtime, you can react, or you make sure you're predictive. So in this case, the fact that the company is investing on brand new equipment and to be predictive will ensure that they do not have any unforeseen failures in critical assets, and therefore they will be able to meet their clients' demands. And again, as Mo mentioned before, Industry 4.0 is not something we do across the plant. We have to find the critical assets. We are not throwing out preventive maintenance or other procedures and tools that are in place. We're just making sure that the organization is not caught by surprise when something unpredictable happens in a very highly utilized line, even though the line is brand new. So Mo, we can go to the next slide. In this case, we had the importance was a milling cell as well as a friction stir welding cell. You could see there were 3 templates deployed for the milling machine, spindle bearings, tool wear, and ball screw, and then spindle bearings, for the friction welding machine. Again, capturing the data was important. Here, what you see is actually the data. Okay, you're seeing the elements that we talked before, where the problem could arise, how the data was gathered, where a vibration sensor needed to be added, or where the data was available through the controller, some of the sampling frequencies, and then, as you could see, most of the data is coming from the controller. Some of it is coming, vibration data was coming through an external duct that we used from National Instruments. Very, very low cost to implement and very, very fast implementations. I don't remember if Mo covered it, but effectively we can take a machine and set up the sensors and have a pilot running in about 3 months. So these exercises are not years and years to return ROI. You're able to return ROI very, very quickly. Again, you've already seen this slide. We were looking at spindle, the dresser, the y-axis and the z-axis, vibration, motor current, spindle speed, feed rate, and so on and so forth. I don't believe most spend a lot of time describing this diagram, but this is the user interface. Very easy to use from anybody, in the manufacturing plant. This software is showing you the green flat line where it says health assessment, which is highlighted in blue. That's the training session. Then it shows you the health, which is green. It shows you the yellow, and then eventually a prediction of when something would fail. And it also allows us to identify, based on the time that the machine would fail, whether our spare part strategy is sufficient to procure parts from the time we get the yellow signal to the time the failure will occur, which is when we cross the red line. Why is that significant? ROI. You can imagine if I have multiple machines and I have to have X number of hardware sitting around for service parts, we may be able to reduce that by half or down to a third and effectively save cash that is idle spare parts sitting in your plant. The other beauty of this thing, it is fully automated. It works in tablets. It sends messages on your cell phone, or a tablet on your computer sends you an email. So there is really not much that you need to do. Now, the tool goes much, much deeper, which allows engineers, and if you want, obviously, we can drill in another situation much, much deeper of what this does. But our engineers in the plant actually have the ability to drill down to the actual data, look at how the machine was performing originally, and then how the machine is deteriorated, and identify those root causes. And that is important because not only does it predict, but it also educates our engineers of the trends. And as that knowledge builds up, then obviously it helps the organization be much more responsive. Next one, Mo. So finally, IoTeco Academy, a company by the name of Plasman that we've acquired. They have high lines, they have some brand new equipment, and they have some old equipment, and they were not very sure where to start. Where do they start in benefiting from Industry 4.0? So in this specific case, Mo, if you can go to the next slide, what effectively tried to do is do an assessment. Okay, so we had the company come in, visit the plant, and do a full assessment of the current state. And really, the assessment involves 6 steps that have been developed. And the first step is manufacturing strategy, which is really people and process. What's your manufacturing strategy? What are the critical manufacturing processes that are used? What are the product volumes and mix? What drives ROI for your business? This is very important. And I mentioned before, just because you have a tool, it doesn't necessarily make sense that it's going to return an ROI. It has to be a critical tool. It has to be a tool that if the line goes down, the impact to the business is very high. Maybe you shut down your customer, maybe you have to work overtime, maybe you have to do premium shipment. So we need to understand the pain points relating to the manufacturing strategy or the requirements and the expectations that the customers have from this plan to decide what is critical. Now then, plant connectivity. Once we identify those assets, we need to make sure that those assets are connected. Data, right? Critical assets and components. We need to find out their capability, and then we need to develop a data collection strategy. Once we understand that, we need to evaluate performance analytics, which is review the shop floor metrics that we are going to track. We need to evaluate our continuous improvement tools, as well as the tools available for the operators. And then we need to go to operational management. Most companies do this, today: production, quality, maintenance, traceability, maybe not as often, but if the customer requires it. But the question is, to what level of automation is the organization capable of executing the manufacturing operations management? And then there is where most of the plants stop. The next step is, how do you take the organization that now has understanding of the critical assets, they are connected, they understand what are the metrics we're going to track, what are the KPIs, which in many cases exist. As I said, manufacturing operations management has KPIs relating to production, quality, maintenance, and traceability. But now how do we go to the analytics? Processing the data and effectively getting predictive maintenance as well as predictive quality, as Mo described in previous slides. Predictive maintenance comes first, and once we have the predictive maintenance capability and we understand and predict whether the machine will fail, we can then move into predicting the process and how the process is being affected by monitoring those parameters. And then, as the example Mo showed in casting, be able to do predictive quality and eliminate subsequent manufacturing from the process to minimize scrap costs. And obviously, in order to do all of this, in order to make all the data and everything that is happening available, you need to work with your IT team. We need to work with the supporting systems. We need to work with the systems that are driving the business, the MES systems, the ERP systems, and then how are these systems used by people? And I will emphasize that many companies have very good data, but the data is not used by the people. It's available, it's nice. We present to management, and I've been many times presented of what a great tool, what it does. But if you really want to get an ROI, this data has to end up in the user that will actually take action. And so once you finish these 6 steps, once you get the supporting systems, you now have the next level of manufacturing above lean, which is what I call Industry 4.0. And so far, I have been very pleasantly surprised in ROI in many of these implementations that we made. And I just simply shared 4 of them with you today, just to get a broad spectrum of how these tools are applied. Well, so again, we covered BWR and MOBEX in industrial IoT, Dura in predictive analytics, and then Plasman in assessment of Industry 4.0 studies. Mo?
Thank you very much, Dr. D.
Thank you.
So in conclusion, and again, please drop your questions in the chat window if you have any. But we wanted to come here today and really give the team a refresher. What is Industry 4.0? What are some of the key tools that are being used today around AI and machine learning? Again, for the business case of predicting maintenance and predicting quality issues and improving. And again, thanks to Dr. D for really taking us through a journey from maybe the lowest level of maturity to the highest level of maturity companies and what they're doing digitally to drive improvements in their operation. And my conclusion is, you know, Industry 4.0 can be done in a very systematic manner. It's about thinking big, having a vision, but starting small in the right asset with the right people to deliver the right metrics and results. And that proof of value allows you to take that template and win and celebrate that win and then scale that opportunity in other operations. And Dr. D very well covered the first piece, which is assessment, and how one organization didn't know what they don't know type of thing, and they were looking to really assess everything. There's also more targeted assessments that can be done. You know, if you are looking into AI and predictive analytics today, there's also some targeted analytics assessments that can be conducted. And the analytics shape the path, or the assessment shapes the path, paves the path toward technical workshops where a gap analysis and a statement of work can be formulated, and allows then the implementation of a very targeted and focused proof of value, not a proof of concept, a proof of value that marries the technology and the business case with a short implementation duration, as mentioned, you know, 3 months or so, and then allowing it to be run for a few weeks or a few months to achieve that ROI and to achieve that performance metric that you've been seeking. And then allows training capability. One thing we didn't talk about today is the IoT Academy and how Industry 4.0 training can also be conducted in partnership with folks like SAE, as well as academic institutions and so on. And this allows you to create your internal center of excellence, your COE. That's internal competence to be able to do a lot of the things we talked about in today's presentation. You know, automation skill set, data engineering skill set, in some cases, data science skill set, you know, shop floor, MES and connectivity skill set. So that multidisciplinary team becomes your internal competence team, where you can take that template from the proof of value and you can scale it across your operations. So in summary, if you haven't done so already, start your Industry 4.0 journey today and find the right partners to work with. If you want to strategize on how to do Industry 4.0 in a better way, consider partnering around an Industry 4.0 assessment, which will help you understand what's a short-term and a long-term strategy. And from a short-term perspective, implement a proof of value pilot and make it operational. Continue to think big and have the vision around smart connected factories, zero downtime, zero defects. But do know that it's a journey and it's a phased approach. And there's a lot of digital tools out there, some of which we covered today, but there's more. And they all need to be implemented in a strategic fashion. And keeping in mind that it's not just about technology. In most cases, technology always works, but it is the people and the process and how you upskill your workforce and how you ingrain the technology as part of your daily process. That is the powerful recipe for success when implementing Industry 4.0. Special thanks to Dr. D, and please shoot me an email, abouali@iotco.com, if you're interested in a copy of the presentation. Happy to have some one-on-one conversations with you. And I think there is 2 questions that came through the chat. I think one of them may be interesting for Dr. D. Dr. D, it's more about the ROI calculation, you know, some of the use cases you showed today. Any advice for maximizing the return on investment from some of these use cases?
You have to be strategic. Like I mentioned, you don't apply these tools everywhere across the plan. You need to know where the pain points are. You need to talk to the people. You need to, my advice would be talk to your financial guy. Financial guys, what I call plan controllers, know where the costs are high. They know which line got hit, which line goes down. They have profitability by part number in the automotive industry. This is very, very common. And obviously a part number is built on a line. And my hope is that those two pieces of data will actually correlate, meaning when you talk to the people on the floor, they will tell you which line has issues, which line goes down, which line fails unpredictably. And then once you identify that, your ROI will be for sure. And let's be clear, it's a tool. So we can all agree that if a plant has a problem and people work on the problem, they will improve the situation, whether they use these tools or not, right? What I'm emphasizing is the investment to put these systems in place doesn't solve the problem one time, but it allows you to solve the problem indefinitely and monitor the problem. So not only does it give you ROI because it solves the instance that will not happen next time, but it will ensure that nothing will happen over a long period of time in all the parameters that one is monitoring. So choosing the right process and putting the right tools in place, it's the maximum return of assessment or investment. And that's why doing an Industry 4.0 assessment is very critical. Sometimes someone at the high level might engage and be excited about this process and say, let's put it on this line. That's not necessarily the best way to do it. You have to gather all the data, understand the problem, and then apply to the right place. We have never failed when we applied at the right place. So that's how you maximize your ROI.
Thank you so much.
Yeah.
Also, I think if some of the audience members want to unmute, they'll be able to ask questions if you have audio, but feel free to drop in questions or unmute. Yeah, I think also a question that we have is around, what are some of the key technical challenges from implementing some of these things? And I can just briefly address that. I mean, in the first slide of my presentation, there was the automation pyramid, the old school ISA 95 pyramid. And there is actually challenges on each of those layers when you implement Industry 4.0. There's challenges on the shop floor to get data from old machines, for example, that you might need to sensorize. Nevertheless, there's very low cost sensors and hardware available nowadays. So imagine $300, you can get a piece of hardware and off the shelf, and you can augment your machine, and you don't need to retrofit the machine. You can capture data. And then on the execution layer, many companies have a gap in that they have outdated MES systems or outdated ERP systems, monument systems, sometimes we use the term, and obviously integrating with those IT systems is difficult. But again, nowadays there is API interfaces available. There is protocols like MQTT and OPC. So there is more openness to integrate with new systems as well as legacy systems. But one of the key technical challenges is actually less on the technical and more also on the change management. And once these solutions are implemented, there is need for training, there is need for changing some of the processes, there is need for having people start using the tools. So having an intuitive experience for the operator, an intuitive experience for maintenance and quality and so on. So it's at their fingertips, and those, what Dr. D mentioned, tools become ingrained in their daily lives and their daily processes. So the more intuitive change management and training behind the tool, in addition to overcoming some of the technical challenges, allow for that quicker return on investment that can be achieved. So we'll just give it a few seconds. If there's any additional questions, please unmute or drop a chat, and we can conclude the webinar in the next few seconds. Special thanks to the SAE. It's a pleasure to partner with you on this webinar and more webinars to come. I believe you'll be also able to access the recording from their website or their YouTube in the near future. So feel free to visit sae-detroit.org. And please email me if you'd like a copy of the presentation. Happy to have further conversations on this. All right, I think, thank you so much, everybody, for your time today. Special thanks to Dr. D for your contribution, and have a great day, great week.
Thank you. Goodbye.